Big O is a super important concept in computer science, and it's really looking at the growth of functions. And has a lot of applications, especially with algorithms. You can really look, well, how fast do certain algorithms grow? So that's sort of the application, but the main definition is that a function f of x is big O of another function g of x if and only if there exists some constants c and k such that f of x is less than or equal to c times g of x for all x greater than k. Okay, and this is just a really fancy way for saying that f of x does not grow faster than g of x. So it has to grow slower or at the same rate as g of x. And let's visualize this below with a graph because I know it's a lot to wrap your head around. So let's draw g of x first. Whoa. If I can draw well. Okay. And we'll label that g of x times c. C can be any constant. It can be like 5, it can be 100, 3,000, whatever. It doesn't matter, but that's how we're going to represent it. And let me just color code. That way we can keep things together. Okay, and now we're going to have another function. We can have it be a bit wild at the start. Okay, and this is f of x. We're gonna let's give it a cute green color. So essentially we have to find some x value where from then on f of x will always be slower than g of x. So if we look here, this will be our k value. If x is greater than k, so we're looking at this part of our definition, f of x is always growing slower than g of x, and we can just see that visually. So yeah, that's big O in a nutshell. So normally you'll be given some functions and you'll have to be able to find a k and c value in order to prove that your function is big O of another function. And I'll show in later videos some examples of how to do that.